black holes are celestial bodies invisible to the human eye. Even small black holes can relentlessly devour massive stars. When an object approaches a black hole, it is stretched into a noodle shape by tidal forces, then spins rapidly within the black hole's accretion disk, eventually falling into its interior until completely absorbed. So, why can black holes devour everything? How bizarre is their formation process? According to Einstein's theory of general relativity, gravity is caused by massive objects bending spacetime. When a celestial body is compact and massive enough, spacetime is warped to an extreme degree. This is what we call a black hole. The gravitational pull of a black hole is so strong that even light cannot escape, which is why we cannot see them. However, astronomers can still detect celestial bodies orbiting unseen objects or discover accretion disks formed when black holes absorb accretion, thus confirming the existence of black holes. As we all know, stars like the Sun typically have enormous masses and, theoretically, would collapse inwards due to their own gravity. However, the Sun's nuclear fusion process generates outward pressure, creating a balance with gravity that allows it to continuously and stably emit light and heat. However, when a massive star reaches the end of its life and its nuclear fuel is exhausted, this balance is broken, ultimately leading to the collapse of its inner core and a violent reaction in its outer layers, resulting in a supernova explosion. Furthermore, if the inner core is massive enough, it will continue to collapse, becoming a small black hole on a stellar scale. But the Sun is a medium-sized yellow dwarf star, not large enough to become a black hole. Calculations show that only stars with a mass approximately 20 times that of the Sun have a chance of evolving into black holes. Once a black hole forms, it becomes an insatiable monster. In the early universe, with abundant celestial bodies, it would devour nearby stars, planets, interstellar dust, and even smaller black holes of the same type. Its mass would then increase until it grows into a supermassive black hole. For example, the image of the M87 interstellar barycentric black hole, released by the World Telescope in April 2019, shows a supermassive black hole with a mass 6.5 billion times that of the Sun. The image reveals that the black hole itself is not directly visible. The dazzling light surrounding it is the sparks generated by friction as it feeds on matter. The boundary of the entire black hole is called the event horizon, and theoretically, anything, including light, once it enters the event horizon will never be able to escape. Therefore, no one can currently say for sure what's inside a black hole. However, one can imagine what we might see if humans were to successfully enter a black hole.